So we're going to be now solving a quadratic inequality. So inequalities, remember, have multiple solutions, right? Anytime it fits the criteria, it's an interval from here to here. A lot of solutions get to come into our answer set. So let me just read this to you so that you can understand what this is saying. This says, when is the quadratic function less than 0? When is the quadratic below 0? Now here's my quadratic. I have it graphed. Here it is. When is it below 0? Now that means when's the function below 0? So that'd be our y value. Where are our y values? Here's my y-axis. Here's 0. So is it from here? Aren't these the y values that are below 0? Yes. Now we answer our answer is in intervals for x. From this x value to this x value, our function is below 0 for y. Does that make sense? So let's see. Where does my solution start for x? At -1, right? Up to 5. Those are the x values where our function's below 0. Now, does it include 0? Or equal to 0? So right here, right on there, boom, boom, at -1, it's equal to 0, so we get a bracket. Then at 5, because it says we're equal to 0, that's where it's equal to 0, it also gets a bracket. So what would make it parentheses? Well, if they didn't have the or equal to sign, that means just when's it below 0 but not equal to 0. You'd say from -1 up to 5, but then you would just do parentheses because it doesn't include 0. Does that make sense? Including bracket, not including parentheses. Really easy stuff. Now, okay, so let's do this one then. Let's answer this question. When is the quadratic greater than 0? Let's highlight where that happens. When's the quadratic above 0? Here's 0. Isn't this where it's above 0? Here and here. So what would our intervals for x be? From -infinity up to -1, right? That's when it's above 0 for y, right? And then, so does it include 0, this one? No, so parenthesis always with infinity, union, and then doesn't it start from here? From 5 to infinity, it's above 0. Pretty easy, right? Especially if you have a graph. Does that make sense? Now, looking at this one, let's answer it with a graph. When is this quadratic greater than 0? So, when is it greater than 0? Isn't that from here to here? So you'd say for x, values from -1 up to 5, not including either of those. When is it below 0, everyone? From -infinity up to -1, union 5 to infinity. Because it's just x. We answer in x's, but it's our y values that we're answering for. Okay, now here's the thing. We don't want to have to graph these. That's extra work. So how can we solve these with instead using just some algebra? I'm going to show you. We're actually going to solve with algebra because we don't want to have to graph them ourselves. So what we can do, guys, is since this says when is the quadratic less than or equal to 0, if we didn't have a graph, we could say, okay, well, since it's less than or equal to 0, we could find our zeros and put them on a number line. So put them on a number line like an X number line here. And then we could test intervals and see which works. So for example, because it's less than or equal to 0, let's find the zeros. So we would factor this because that's how we find solutions, or x-intercepts, or zeros, same thing, right? We'd factor it. We'll multiply to be -5 and adds up to be -4. 1 times 5, -5. So that factors to be x plus 1 and x minus 5. Therefore, our zeros are -1 and 5. That's where they're getting these from. So you'd go -1 and 5. And then we're literally just testing, look, this is our x-axis. We're testing intervals to see where it's a true statement or not. So then you literally just plug in some values and state yes or no. So let's see if it's a true statement. Let's plug in something below -1. Like, let's plug -2 into our function here. So using algebra. -2 squared minus 4 times -2 minus 5, is that less than 0? Let's calculate it. 4 plus 8 minus 5, is that less than 0? 8, 9, 10, 11, 12, right? So 7, is 7 less than 0? No, so no, that is not in our solution set. Which, well, look, we already said no with our graph. You guys see? It's just using algebra instead, so we don't have to graph it. You guys see? Okay, then from there we would plug in a value between -1 and 5. I always plug in 0 if I can, because that's the easiest. Look, 0 squared minus 4 times 0 minus 5, is that less than or equal to 0? Let's see. Oh, it's Negative 5 is less than or equal to 0, so we'd say yes here. And then we'd plug in a value above 5, like 6, and then you get a no. Then you'd say, does it get to include 0? Equal to, yes. So then those zeros, which are these little values on my number line, these are the zeros right here and here. So those are yeses, because it says equal to 0. So that's yes and that's yes. So where does it say yes? From negative 1 up to 5. Oops. From negative 1 up to 5, right? And then the yeses mean brackets. So it's the same thing, it's just that we don't have to graph it. Does it kind of make sense? Just testing intervals, seeing where it's yes or no? Okay, and then yeses get to come in our solution set. So look right here, what would have happened was, on our number line, we would have our zeros, which would have been negative 1 and 5. We would have tested in, we would have plugged in something less than negative 1. We would have got this. Yes, no, yes. That would have been a true statement, not a true statement, a true statement. So then you can see wherever the yeses are our solutions. So from negative infinity up to negative 1, you guys see how it works out the same way? This is where the yeses were. And then from 5 to infinity, and then you'd say, does it include 0? No, so not including that, not including that. It's just a different way of getting the answers. Yes? Oh, for 10, you can take sec 3 light or sec 3 regular, but you do have to take sec 3 to take 10 times. Yes, but it is going to be a hard class for them as long as they understand we're going to have to work hard. Yep. Okay, so no. It's either going to be both brackets or both parentheses. So this is either going to be equal to 0, and that would be both of them, you know, or it would be one is and one isn't. Great question. Okay, so here are the steps. Here are the steps. So we're not going to want to graph them, and we can solve by graphing if we really wanted to, but I don't want to graph them. Make a number line and test values. Here are the steps to solve a quadratic inequality. First, get it set equal to 0. Why? Because we can find zeros the easiest. Making our life easier. If we had it equal to 10, we're going to have to find increments for this quadratic being greater than 10. That's going to be a lot harder. Let's just get it equal to 0, and then we're just testing zeros. Then second, solve by factoring our quadratic formula to find our critical values. So then from there, we'll make a number line with those critical values, those zeros, as you've seen me do, and then test out values of different intervals, and then you'll get yes and no's, and that'll be your solution. So let's just go through this one with the steps. First, get it equal to 0. So that would be x squared minus 3x minus 10. When is that greater than or equal to 0? Now from there, solve. So let's do full factoring. What multiplies to be negative 10 and adds up to be negative 3? Right? 5 and 2, negative 5 and 2. So then from there you would say, so it factors to be x minus 5, x plus 2. So then our solutions are x equals 5 and x equals negative 2. Those are our critical values. So you'll draw your number line, put in your critical values, negative 2 and 5. And then you're literally just going to plug in values and say yes and no. So now, was it including 0? Including 0? Yes? So these are yeses, because they are the zeros. Those are the including part, so yes on those little guys. And now let's start plugging in some values. So let's plug in negative 3. So that'd be negative 3 squared minus 3 times negative 3 minus 10. Is that greater than or equal to 0? 9 plus 9 minus 10 is greater than or equal to 0. That'd be 8. Is 8 greater than or equal to 0? So we'd say yes here. Let's plug in a value between negative 2 and 5. Let's plug in 0. So that would be negative 10. Is negative 10 greater than or equal to 0? Showing my work. No, it's not. So we'd say no. And then it is going to bounce. So the next one will be a yes. I would at least test 2 though. At least test these 2, just because then you can catch errors. If you get yes, yes, you know one of them's wrong. You tested one of them wrong. Because it will bounce. In all but one case, and I'll tell you that case in a second. So let's write, now just put your answer. That helps you just put your answer in interval notation. So yes, from negative infinity up to negative 2. And then it's a yes on negative 2, that's a bracket. Union, then it's no, so we gotta skip over that. Then we get to 5, it's a yes, and then it goes to infinity. Pretty easy.
So only
we just tested intervals. Like something on this side, something in between here, something over here. So there's 3 intervals we tested here. Another one. You know what just hit me? Oh man. Oh man. In all the other hours, we haven't done any where they had to use the quadratic formula, and you will have that happen. So I'm glad I realized it, because now we can do one at least for the video. Because they all just thought it after this next example, like, we're good, so then we just let them go, but then I didn't think about it. Okay, let's do this one though. Okay. Yeah, we could subtract 3x, but I always want this to be positive, so if I do that, that's fine. But then I can't quick factor, and then there's so many ways we can go about it though. So I'm going to actually go the other way. I'm going to add. Is that okay? This is different than I did it last hour, but it will end up being the same answer. So add x squared, subtract 10. Add x squared, subtract 10. Now we have a 0 on this side. 0 is greater than, and then we have x squared plus 3x minus 10. Now, we usually like to write this the other way, so let's rewrite it. We have x squared plus 3x minus 10, but then make sure it still munches on the right thing. Munch, munch on 0. So it needs to still munch on 0. Are we good? Then from there you'd say what multiplies to be negative 10 and adds up to be 3. 5 times 2, negative 2. X plus 5. X minus 2 are yours almost 0, so x equals negative 5 and x equals 2. There's your critical values. Here we go. Negative 5, 2, and then let's test intervals. So everybody, let's plug in something below negative 5. I'm going to plug it in here. So that'd be negative 6 squared plus 3 times negative 6 minus 10. Is that less than 0? Let's see. 36, and then it looks like minus 18 minus 10. Is that less than 0? 36 minus 28. Is that less than 0? No. So this is a no. So then this will be a yes, but you're going to, on the homework, at least check the next one. And then the next one will be a no. So now from here we can say, so the yes was between negative 5 and 2. Does it get to include 0? No. So these are also no's. So then parentheses. There's your answer. Okay. So these all have factored, which have made it easy. It's the same idea with the ones that don't factor. Let's just do one that doesn't factor. This one's easy though, right? It's already factored. So I won't go through the whole thing, but what would my critical values be? 5 and negative 2, and then you just test it, right? And then you can just plug it in right here, right now. Are we good with that? Okay. Okay, this one factors 2. This one is the one. This one, write it down. Okay, this is one that doesn't factor. I can't believe I didn't think about that. Ding nabbit. Okay, so let's go 2x squared, subtract 4x, add 1. When is that greater than 0? So look, if you try to factor it, what multiplies to be 2 and adds up to be negative 4, nothing. So we have to do the quadratic formula to find our zeros. So x equals negative b plus or minus the square root of b squared minus 4 times a times c. And then that's all over 2 times a, so that'd be all over 4. Don't divide out the 4s. So x is equal to 4 plus and minus the square root of 16 minus 8, isn't it? All over 4. So we have x is equal to 4 plus and minus root 8 all over 4. Then we go off to the side and say square root of 8 breaks down into 2 times 2 times 2. So now we would have 2 root 2. So then we have x is equal to 4 plus and minus 2 root 2 all over 4. Yep, and then we can separate them, or let's hurry and actually divide out a 2 out of all those. But then we will separate them. Okay. Oh man, I'm so glad I thought of that. So we have x is equal to divide by 2, 2, 1. So divide by 2. So then we have 2 plus and minus root 2 all over 2. So there's our critical values. 2 plus root 2 over 2, and then 2 minus root 2 over 2. Now, I personally would rather put on my number line a decimal. So take your calculator and do 2 minus root 2. You have to hit enter next and then divide it by 2. Give me a decimal. 2 plus root 2 divided by 2, give me a decimal. It's going to be a rounded decimal, but we'll be good enough. What is this approximately equal to? 1 point something? Which one's 1.7? So 1.7. What's the other one? What is it? 0.29? Yeah, could be. 0.29. So Obviously 0.29 is smaller, right? 0.29, and then 1.7 is larger. So no negatives here. That's okay though. So let's start plugging in values. So this will be easy though. A number below 0.29, maybe 0. Okay, let's go back to the, I gotta see what the original was. 2x squared, okay, 2x squared minus 4x plus 1. 2x squared minus 4x plus 1, is that greater than 0? Let's plug in 0. Plugging in 0, we get 1 is greater than 0, true? So this will be yes. So if we plug in, so we obviously know it's going to be no, then yes, right? But let's make sure, let's plug in a value between 0.29 and 1.7. 1, I like that, so easy. 2 times 1 squared minus 4 times 1 plus 1, is that greater than 0? Let's see. 2 minus 4 plus 1, is that greater than 0? Negative 1 is greater than 0? So no, so yes. So now from here, we'll write our final answer though back in these radicals. So this was actually 2 minus root 2 over 2, and this one was 2 plus root 2 over 2. So now we'll just go, it's not that it's any harder, it's just kind of uglier to write. So we're going in, coming in hot from negative infinity up to 2 root 2, 2 minus root 2 over 2. Is it equal to 0? Do you remember? Was it an equal to? Okay, so then parenthesis, union, and then it's yes from 2 plus root 2 over 2 to infinity. It's not any hard, same idea, it's just getting the zeros aren't easy. Yeah. No, I think putting it back like this is what would be better, because that's exact versus the decimal just helps us think about it easier for testing. You got this? You got it? Okay, awesome. We're almost done. This is the last part. Okay, it says find the domain. Let's see why. We've already learned this. We've already learned both of these. So let's see how we'd set this up. Everyone, find the domain means find intervals of x for which we can be, which we can plug in, right? So isn't it true the square root, a square root can have on the real number line positive numbers. The square root can have a 0, but the square root can't have a negative on the real number line for x. Okay, so isn't it true to say whatever's under the square root, no matter what it is, needs to be greater than or equal to 0? True? Okay, so then you'd add 8. So x values need to be greater than or equal to 8. That one was linear, so linears are easy to solve. So then in interval notation, x values greater than or equal to 8, that would be from 8 to infinity, including a parenthesis. There's our solution, right? Now right here, let's see, how would we set it up? Isn't it true that no matter what's under the root, x squared plus 8x needs to be greater than or equal to 0? And now look, you're solving what we just learned how to do. It's a quadratic. How do we learn how to just solve the quadratic one? Get it equal to 0, factor it, test values, right? Yeah. So you'd say factor it. So then our critical values for a quadratic are 0 and negative 8. Then you would like test it, yes, no, yes, or whatever. And then there's your domain. So it's just, you had to set it up wherein this one it just says solve. But you guys see how it's solving the same thing, essentially. Because once you set up a true statement, it is just solving an inequality. That's quadratic. Are we good?
Where did you go from x?
We set them equal to 0, right? We find the zeros, which are our critical values. And then we're going to test intervals. Just like we did in every single one of these examples. We found the zeros, and we tested intervals. Look, this is literally the same true statement that you're looking at. A quadratic is below 0. A quadratic that's greater than 0. Do you see how it's the exact same connection?
I'm not sure what.
When we factor, we've been solving.
I get it on these problems.
Well, this is not any different. How do we solve x times times x plus 8. How do you solve? Set each of them equal to 0 and solve. So we get x equals 0 and x equals negative 8. So there's our critical values test interval. Are we good, guys? Okay, awesome. Go practice something like that because that is new to us. You guys did really good though.